Hi, my name is Jim Lee. I'm president of Symmetrics, and I'd like to talk with you about Analytica, our analytics offering for buildings, energy efficiency, operations, and continuous commissioning. So to start out with, I'd like to introduce you to Symmetrics. Symmetrics is a 28-year-old company whose core competency is physical world analytics and the Internet of Things. We have two divisions in Symmetrics. Our products division, which is best known for BACnet, where we have approximately a 60% market share worldwide in the underlying BACnet that we offer to the controls industry. BACnet, for those of you who don't know it, is the ANSI, ASHRAE, and ISO world standard for building automation communication. BACnet was approved as the ASHRAE standard in 1995 and is the dominant building automation communication protocol in the world today. Symmetrics manufactures BACnet protocol stacks, BACnet protocol analyzers, explorers, web services, routers, OPC servers, sub-metering interfaces, interfaces to SNMP devices. We also have a legacy RS-485 networking product line. In 1998, we began working on Analytica, which is effectively a full solution which connects to existing building automation elements in a building and mines data and provides enterprise applications for customers to view that value. So I'll talk mostly about Analytica, but first, a little bit of a slide of our BACnet customers. As I said, Symmetrics forms the underlying BACnet communication in about 60% of the world's BACnet products. Here's a list of those customers. We also founded the BACnet Testing Laboratory and BACnet Manufacturers Association, which is now called BACnet International. And we operated that test lab for the first 6 years of its inception, since its inception. Okay, switching to talk about Analytica. In 1998, we had done most of the technical heavy lifting to create the plumbing for the communications of the industry, but our viewpoint was that most of the value was contained in the information that was in the buildings, and no one was really doing anything material with that information. So at that time, we began looking at ways to take data from building automation systems, fire alarm systems, elevators, security systems, process systems, figure out how to take that data and turn that data into value for building owners. And we first started out with fault detection, diagnostics, and optimization. And early work was being done at the time by the DIST Building Fire Research Lab, and we adopted some of that fault detection and diagnostic work and began to apply it to the big data we were collecting from buildings to find things like I was never installed correctly, running continuously, stuck in the open position, or my control sequence is backwards. So what we actually do is we connect to the existing building automation systems, sub-metering systems, industrial and process control systems, sub-meters, etc. We put a black box at the site which gathers data from those building automation networks, stores that data in a secure form over the internet up to a large private cloud, which is running here in Boston. Acting on that private cloud, we have a series of algorithms predicated on mechanical, electrical, and energy consuming systems. And we mine that data to show building owners savings on energy, maintenance, operations, regulatory issues, and comfort on an ongoing or continuous commissioning basis. So we connect to the data, we move it up, store it, we mine it, and then we present those results to the building owner. In 1998, we first had the perception that this would be an online service, a web-based, cloud-based service. And we quickly discovered that building owners wanted much more. They actually wanted a high-touch, technology-enabled consultancy where Symmetrics would look at the results of the algorithms that were generated and then step down and actually help the customer solve the problems that existed in their buildings. And that's what Analytica is today. The ability to collect the data, store it, mine it, and then present operational recommendations to building owners and help the building owners effect changes in those facilities. The value proposition. There is a 10 to 20% hard savings off of the HVAC energy spend without capital investment. That is in keeping with many continuous commissioning regimes, and there is quite a bit of academic and business literature to support those assertions. And we have now 17 years of experience to show that in fact 10 to 20% energy savings off of the HVAC energy spend is a very reasonable number to expect. For maintenance, predictive maintenance, we have, as an example, we have a Belimo VAV actuator, which is rated for 65,000 cycles over its life. If the PID loop that is driving that actuator is oscillating, the actuator will burn itself out quickly, maybe a year and a half. If the PID loop is tuned properly, that VAV box may last for 15 years. So those are the kinds of predictive maintenance value propositions we can bring. With energy, the Iowa Energy Center has done an excellent study that shows that 33% of problems found in buildings are attributed to operator error, unawareness, interference, or indifference. Now, the question is, are operators trying to do a bad job? The answer is, of course not. What is their job? Their job is, whenever they get an alarm, is to log into the computer system and make that alarm go away. So for instance, if they have a cold complaint in the corner office, they're going to log on to that system and raise the reheat in the corner office, solving the temperature problem. But whoever looks at the underlying physics of what they've done, the answer is probably no one. So after operators on first, second, and third shift have done their job for a few years, they end up driving that building around with their foot on the gas and brake at the same time, having introduced simultaneous heating and cooling all over that building. So that's an example of how the oversight of Analytica can improve efficiency and save energy, in fact, on operational problems. Comfort, there's a great value proposition in terms of occupant productivity and comfort. Commissioning, greenhouse gas emissions measurement, and potentially the stickiest of all value propositions that we offer is regulatory monitoring. So for instance, air changes per hour in hospitals for Joint Commission regulation, or FDA regulations in pharmaceutical facilities. So I've talked a lot about many high-level issues, how we're going to connect to building automation systems and create value, but what is it that the user actually gets? And what you get is a table that looks like the following. And in that table, what we have are issues. So what's happening is that the computer is mining that data from the building automation systems. It's creating faults. So fault tables are being created as to where equipment components are not working with respect to the model. And then those faults are then synthesized into issues. And those issues are actionable information, as you see on the screen here. So the first item says central chilled water plant not optimized, low temperature in the primary loop with multiple chillers running. We put the date that we found the problem. In every period, the computer is going through the underlying data to see if the problem is fixed. So No contractor with a clipboard saying, yes, I fixed it or I didn't fix it. Just the naked physics coming out of the computer every period. So effectively what we've done is created enterprise management for building operations, or an oversight system that actually ensures through physics and math that the problems are fixed or not fixed. And that's a very important, that enterprise management of these building maintenance functions is a very important step forward in the evolution of systems in the building automation industry at large. Several points are questionable or appear to be duplicates. Next one here, you can see that it was found, but it was not fixed. So now we have an opportunity to have a dialogue with everyone in the ecosystem at the building's facility, at the owner's facility, to make sure that those problems are getting fixed. Next one, some of the air handling units are overventilating based on building design plan values. Another configuration issue perhaps. Once again, it's been found but not fixed. We then go on to actually calculate how much energy you're wasting issue by not fixing the problem. So we're actually putting energy waste numbers, if you will, around the issues that we found. So that central chilled water plant issue is costing $27,000 a year annualized. And excess hours of operation of air handling units, $7,600, and exhaust fans commanded on during excessive hours, $1,300. And if you look at the last one, economizer cycle not optimized, you see that we're actually only, the machine and the analyst working on this are only giving 90% credit. So it's not a binary fixed or not fixed issue. There are degrees of fixedness. And these savings calculations show that level of granularity. Now, it's very obvious that having these numbers makes it easy to prioritize which maintenance items you want to fix. We can see that excess hours of operations of the air handling units is $7,600, and the chilled water problem is $27,000, but it might just be a very quick change at the workstation to get the $7,600. The $27,000 might take more investment. So prioritization is the number one thing that can be done with these numbers, but really the second thing that's much more important is that these numbers represent data that was unavailable to facility managers before. And in fact, if you were to look at most large institutional real estate portfolios across the country, they have billions of dollars of maintenance backlog. It's not uncommon for a large university or a large hospital to have $1 billion of maintenance backlog. Why does that backlog exist? Primarily because the VP of Facilities has been unable to articulate to the CFO why an investment in these particular items would afford a payback. Because the granularity of the measurement of energy waste in the building has only been the main meter. And I think that we all know that the signal-to-noise ratio of the main meter is not going to capture energy components as small as the ones we're looking at here. So in fact, you can view Analytica as a giant calculated submeter using big data to calculate energy waste down to the terminal energy wasting devices in the building. And that is the power of Analytica will allow you to break out of this inability to benchmark maintenance backlog. Now that VP of Facilities has the ability to go to the CFO and say, for this amount of investment, I can fix the problem, and through this measurement and verification of Analytica, I can guarantee to you that it's fixed. Once we have the energy numbers, we go on to actually calculate carbon equivalents. And for those people that have sustainability programs, the carbon equivalents down to, once again, the terminal end carbon consuming device, emitting device, wasting device, if you will, is available, and now we can do something material about remediating that carbon. We then go on to provide the underlying information. What was the data that we collected to arrive at the conclusions? What were the assumptions that were made in those conclusions? And then we actually show open book savings calculations. So how did we arrive at the conclusions, and what is the substantiation for both the technical considerations as well as energy savings? And finally, we go on to make recommendations as to how the problem should be fixed. And Marco Rubio moment.
I concur.
So we would like to go on next and talk about some real enterprise examples of Analytica. This example that I'm giving is one that we call vendor management. Many large institutional real estate owners have completely outsourced their mechanical and controls maintenance, or potentially even more components of their facility operations, to third-party contractors. There are several large companies that are in the business. The example that I'm giving now is one of a large pharmaceutical campus in the southern United States. And if you look across the bottom of this figure, these are the buildings represented. If you look at the green bars, those represent different issues and energy waste associated with those issues. If you look at the orange dots, they represent the number of days that it took that outside contractor to fix the problems. And if you look at the yellow line, which is there at 60 days, that's the service level agreement for when the contractor agreed to fix the problems. So you can see that at this multi-million square foot, very expensive